Start, sir.
Okay, good morning students. So yesterday we are discussing about the chapter Metallurgy. So in this we are seeing minerals and ores, that shortcuts also we are provided. See in that metallurgy, what are the main important points? So that is first, purification of ores. So first the step is the purification of ore. Next, after this, second important point, that is preparation of crude metal. So first one is purification of ore. Second, ore is purified after we are preparing crude metal. Next, after preparation of crude metal is nothing but impure metal. Crude is nothing but impure. So now, refining of metal. So third process is refining of metal. So otherwise, purification of metal. So mainly in our metallurgy is nothing but extraction of metal. So that is in three processes. First, purification of ore. Second one, preparation of crude metal, otherwise impure metal. Next, this impure metal is prepared as a pure. That is a purification of metal. So here, what are the processes are there? So just I am giving one line of shortcut. Just hemophilia. See, what are the processes in the purification of ore means? Just you see, hemophilia. So hydraulic washing, magnetic separation, froth flotation, leaching process. These are coming under the purification. So in your entrance, what they will ask, which of the following is a purification of ore method? So like that. Next, one by one we will discuss. Next, in the preparation of crude metal. Preparation of crude metal contains ore. So O means oxidation process. Next, reduction process. So in oxidation, we have corrosional. So just you remember ore, corrosional. So oxidation, we have calcination and roasting process. In reduction, we have smelting process. Next, in this reduction process, we are discussing the famous thermodynamics. We are applying in metallurgy. So thermodynamics versus metallurgy. So that is explained by Ellingham diagram. So which one is reducing which metal? So no need to buy heart and all those things. That experimental data in thermodynamics, spontaneous process gives free energy. Based on that, we are identifying this one. So in the preparation of crude metal, we have two concepts: oxidation, reduction. In oxidation, calcination, roasting. In reduction, smelting. So in smelting process, we are discussing about Ellingham. Next, in the refining of metal or purification of metal, so here the shortcut is Delhi, Polveku and Yelemo, Bacrozone. See, what are the process in the purification? Distillation, liquefaction, pouring process, besmerization, cupellation, electromagnetic, that electrolysis process, Mann's process, Van Arkel's process, chromatography process. Next, zone refining. See, the great metallurgy, after all one line. Okay, so one by one we will discuss now. So first one, purification of ore. So in purification of ore, so the ore we are extracting from the nature through the mines. So that is converted into small pieces as a powder. So after the formation of ore powder, we are doing main process. So first process, purification of ore. So first the ore is collected. Ore is taken from mines. Next, so this is by using ball mills. So converted into powder. That ore powder. So now the process will be started. So this powder is taken. What is our shortcut? Hydrolysis. See, what are that process? One, hydraulic washing. So one is hydraulic washing, second one, magnetic separation. Next, third one, froth flotation. Next, fourth one, leaching process. So one by one, the important points you are discussed means that is your great entrance. So in this, so first one, hydraulic washing. So in hydraulic washing, what they are doing? See, they are taken a very big tank in that. So from bottom onwards, they are sending water with air. Air and water both are mixing. Next, here from the top, so they are powdered ore. So powder ore they are taking on this. So from bottom onwards, what happens with the high pressure of water with air we are sending. So then what happens here? Whatever the dust particles are present in this. So this is become as a slag or waste material. So all lightweight impurities. So which one has a weight is low. So lightweight impurities are continuously coming and they are moving outside. So at bottom, if you see after some time, so the bottom is completely covered with ore. So this process you call as a hydraulic washing. So in this, which ores are purified? That is important in our entrance. So which ores are purified here means that is oxides. Oxides and hydroxides. Ores. So oxide or hydroxide ores are purified in this hydraulic washing. So that is the first one. Next. Second process, magnetic separation. See, in a hydraulic washing also, some wheel flame method. So will apply method also. Tables. So some useful tables, that methods are there. In hydraulic washing is more effective. So second one, magnetic separation. See, in magnetic separation, what happens? If you take ore contains, see, dot. This dot you can feel the magnetic nature. So next you take circle. So that is a non-magnet. So if the ore contains, one is a magnetic compound, another one is a non-magnetic impurity. Such compounds only you can separate in the magnetic separation. So here we are taken two wheels. So that is combining with turbine. So here the ore powder we are taking. So the rolls are rotating. So the roll is rotating like this. So that means the ore particles are moving on the magnetic belt. So here, this wheel is non-magnet. This wheel is non-magnet. Now, this wheel is connected with magnetic nature. So then what happens if this roll is rotated? So the magnetic natured particles are continuously attached with up to this point. So that's why after this the magnetic is eliminated. So all the magnetic particles are separated this far distance area. So the magnetic particles are coming up to the last end of the wheel turbine. So these are separated here. Next, if you take non-magnet, so non-magnet magnets are ejected far distance because of that continuous rotation. There is no attraction, so these are ejected far distance. So non-magnets are separated one other area. Magnets are separated close to the wheel. So this is a magnetic compound. So this is a non-magnetic impurity. So what is the best example? So that is a wolframite. So already we seen wolframite is what? Combination of so magnetic ore. So that is a WFeO4 compound. The impurity, iron is a impurity with the SnO2. So the wolframite has, the main component is this. This has a magnetic nature. Next, SnO2 is the impurity, that is a non-magnet. So you can easily separate in the magnetic second one. Next, third, froth flotation. So third, you take froth flotation. So in this process, so which one we are purifying? So that is sulfide ores. Sulfide ores are purified. So that is one important point. Next, in this process, what they are doing? See, they are taken one big tank. In this, they are separated with the one partition. They become as two chambers. In this, these are one stirrer. They will take. Next, this outside is surrounded with the air sending. So air, that's it. So in this, this is continuous stirring. Next. So the ore material, the sulfide ore, they are taken here. So sulfide ore, they are taken in this chamber, and it is mixed with two important points. One is collectors, second one stabilizers. See, these are only important in our entrance. What are the collectors? So you write as copy facts. So collectors, what are the collectors means pine oil. Next fatty acids. Next xanthates. So in your entrance, this is only important. So collectors, that is copy facts, you remember pine oil, fatty acids, xanthates. Next, there are stabilizers. So you write as stacrone. So stabilizers are what? Cresols. So organic substance, cresols and anilines. So aniline combinations. See, what happens to this? The ore particle is surrounded with stabilizer, and stabilizer is surrounded with collectors. So stabilizers, collectors are surrounded with ore. So now this ore will be lifted from the water. So both are collectors and stabilizers are mixing, and you are sending a continuous air with continuous stirring. So then what happens? Inside ores, all inside ore particles are covered with layers. So that is coming outside. The ore is covered with stabilizers and collectors. So these are slowly coming to this chamber. See, they are coming into this chamber, and here what happens with high pressure of water, we are sending high pressurized water. We are continuously sending means this is a sprinkler on the surface of this ore. At last what happens? The all ore particles are perfectly coming in the bottom. So on the top water will be absorbed. So water is above. So pure ore particles are coming down. So here the impurities are not become. So impurities are present here only. Only ore particles only covered with collectors and stabilizers. These are coming into another chamber with high pressure of water. These layers will be separated. So pure ore will be coming bottom. So here in this what we are separating, that is the sulfide ore. First point, who is a collector? Pine oil, fatty acids, xanthates. Who are stabilizers? Cresols, anilines. These are the entrance point. Next, if more than one sulfides are there, if more than one sulfide is present, suppose you take zinc sulfide is there, lead sulfide is there. Suppose you are doing this process, so both are coming. So again, zinc sulfide, lead sulfide, both are coming means you can't separate these two. So that's why one we can suppress. So we are using the suppressants. See, the suppressant is depending on what? The nature of the element. So lead is what? P block element. D is zinc is what? D block element. What is the speciality of D block elements? They are readily forming complex compounds. So the zinc, you take NaCN, sodium cyanide. So cyanide is a powerful ligand. So it is surrounded with zinc. So you are getting zinc surrounded with Cn taken 4. So that plus 2. That is dissolved in water. It will be separated. So pure lead sulfide is coming outside. So this is also very important. Suppressant, which one you are using means NaCN. Cyanide is a strong ligand, the removal of D block element points. Next, leaching process. So the leaching. What is the meaning of leaching? See here. The fourth one we are discussing, leaching. So leaching process. See here. Suppose in the ore mixer. So ore mixer contains two compounds, A and B are there. See, one compound is soluble in one reagent, B is not observed, means soluble in another. Suppose C solution, C chemical we are taken. So what is the C chemical compound? See, A dissolved in C. A dissolved in C and B undissolved in C. So such a type of impurity ores only using in leaching process. So then what happens? A is dissolved in C. A and C combined in liquid state. Next, B is not dissolved in C. So then what happens? B is in the form of solid only. So one compound is a solid, another one is a liquid. So you can easily separate it by using filtration. So what the leaching process means? One compound is dissolved in one suitable chemical, another one is not dissolved in that. Such a type of ore and impurity mixers only we are using in the leaching process. So here two important famous compounds, the purification of ores, we are taken as examples. So in your entrance point of view, that examples only important. The famous examples are two. One is purification of bauxite. So purification of bauxite. What is the leaching agent? In this, the leaching agent is NaOH. See here, bauxite formula Al2O3 2H2O. This is contains impurity. So now this we are treated with the NaOH. So alumina, it is dissolved in NaOH. You are getting NaAlO2. Otherwise Na3AlO3. Otherwise, if you take a complex also, so Na2 surrounded with aluminium. So aluminium H2O taken 6 plus 3 complex compound also. So that is the possibility. Aluminium water with hydroxide. So otherwise aluminium OH taken 6. Otherwise here Na3. So the possibilities, so many possibilities are there. So but these all are dissolved in NaOH solution. Next, impurities are not dissolved. So impurities are in the form of solid, these are dissolved. So you use a filtration. So you use a filtration means solids are removed. So you are getting a liquid. So this liquid you are going to heat. So that first that becomes as AlOH taken thrice. Next, further you are heated, it becomes as Al2O3. So you are getting pure Al2O3 plus water. So this Al2O3 in the solid form. So solid again liquid is coming. So you can separate by using filtration process. So the main condition in the ore and impurity, one is dissolved, another one is not dissolved. That is only the basic point for leaching process. Next, second one. So purification of gold and silver. So what is the leaching agent? You can take NaCN, otherwise KCN. We are using here. See that process. In your entrance means which is purified in leaching process. One is aluminium, second one gold and silver. So what is the leaching agent? Previous aluminium is sodium hydroxide, but here leaching agent is sodium cyanide or potassium cyanide. See, so gold and silver are present. Gold and silver, generally native state only it is available, otherwise in any compound state also, not a problem with impurities. So now we are going to separate this one. This is treated with NaCN or KCN. So then what happens? This is a D block element. So the D block element, the famous complex compound formation only. These are powerful ligands. So then what you will get? Ag surrounded with Cn taken twice. So oxidation state plus 1. So that is 2 ligands are separate. Surrounded with that one, so minus 1. Otherwise, AuCN taken twice. So this